Welcome to the Podkey summary of flexible fuel vehicle. Flex fuel vehicles sound like a very specific early 2000s idea, but the basic concept actually goes back to the Model T. And once you look a little closer, the interesting part isn't just that a car can drink different fuels. It's how much that depends on infrastructure, pricing, policy, and a bunch of very practical engineering details that decide whether the feature gets used at all. Brazil turned flex fuel into a real everyday system at huge scale. The US, meanwhile, built millions of capable vehicles that often never actually ran on E85. That gap tells you almost everything about how energy transitions work in the real world. At the simplest level, a flex fuel vehicle, or FFV, can run on gasoline and higher ethanol blends using the same tank and the same basic fuel system. The car senses the mix you've poured in, then adjusts fuel injection and spark timing automatically. So if the tank has mostly gasoline, it handles that. If it has a high ethanol mix, it handles that too. And if you've got some in-between blend because you topped off one with the other, that's fine. The whole point is continuous flexibility, not switching modes like you're flipping a lever. That idea is older than a lot of people realize. The Ford Model T, back in 1908 through 1927, could run on ethanol, gasoline, kerosene, or a gasoline-ethanol mix, using an adjustable carburetor. So in a funny way, some of this is less futuristic than it sounds. It's a modern version of a very old automotive instinct. Make the engine adaptable. This is where the terminology matters. A flex fuel vehicle is different from a biofuel vehicle. In a biofuel setup, like a car that can use gasoline and compressed natural gas, or LPG, or hydrogen, the fuels are stored separately and the vehicle burns one at a time. Separate tanks, separate storage logic, and usually an intentional switch between fuel sources. A true FFV keeps the fuels in one shared tank and just lives with whatever blend is there. That's a much smoother experience for the driver, but it also means the engine management has to be smart enough to adapt on the fly. There are also vehicles that stretch the concept into something even broader. Brazil had the Fiat Siena Tetrafuel, which could use gasoline, Brazil's normal E20 to E25 blend, hydrous ethanol, or natural gas. Chevrolet had the Astra Multipower, which combines CNG capability with gasoline ethanol operation. At that point, the fuel door starts sounding like a menu. Brazil is the big success story here, and it didn't happen by accident. The country had the Pro-Álcool program, mandatory ethanol blending, a long-established ethanol industry, government support, and crucially, actual pumps where people could buy the stuff. That last part matters more than it sometimes gets credit for. By 2006, roughly 33,000 Brazilian filling stations offered ethanol. So consumer choice was real. It wasn't a brochure feature. It was something drivers could act on every week. The growth numbers were huge. Flex car production in Brazil went from about 49,000 in 2003 to 1.94 million in 2007. By 2013, flex vehicles made up 94% of new passenger vehicle sales. And the installed base became enormous. By March 2018, Brazil had about 30.5 million registered flex cars and light trucks, plus more than 6 million flex motorcycles. That's not a niche experiment. That's a national transport system with fuel flexibility baked in. Brazil also shows the catch. People use the flexible option when the economics make sense. In 2009, about 65% of Brazilian flex vehicles reportedly used ethanol. But by November 2013, that figure had fallen to 23% after ethanol prices rose and government policy kept gasoline artificially inexpensive. So the technology worked. The infrastructure existed. Drivers understood the choice. But the market still moved with relative fuel prices, which is a good reminder that adoption is not the same thing as loyalty to a fuel. People do math, even if it's back-of-the-envelope gas station math. The US made millions of E85 capable vehicles, but for a long time a lot of that capability just sat there unused. A surprisingly big reason was that many owners didn't even know they had an FFV. In a 2005 survey, 68% of American flex fuel owners did not know they owned an E85 capable vehicle. That's a pretty hard feature to use if it's basically hiding in plain sight. Automakers later tried to make it more obvious with yellow fuel caps and clearer badging starting around 2008. Helpful? Yes, but that still didn't solve the bigger problem. The bigger problem was infrastructure. In March 2014, only about 2% of U.S. motor fuel stations offered E85. By November 2015, there were 3,218 public stations for a national fleet with more than 21 million capable FFVs, and those stations were heavily concentrated in the Corn Belt. So yes, the cars were out there. The fuel often wasn't. In 2011, the Department of Energy estimated that only 862,837 fleet-operated flex vehicles were regularly fueled with E85. And in 2009, just 1% of U.S. ethanol consumption was E85 used by FFVs. That's the definition of a capability gap. There's also the basic energy math. E85 usually gives lower mileage, because ethanol has about 34% less energy per unit volume than gasoline. The practical rule of thumb in the article is that E85 needs to be around 25 to 30% cheaper than gasoline for drivers to break even, though that varies by vehicle and region. If it's not discounted enough, people feel the difference fast. And the environmental side isn't automatic either. Ethanol's climate benefit depends on what it's made from and how it's produced. Corn ethanol, in particular, has faced criticism over indirect land use change and greenhouse gas impacts that can eat into or even undermine the expected advantage. That helps explain why policy looms so large. In the U.S., automakers were criticized for benefiting from fuel economy credits tied to flex fuel capability, even when owners rarely used E85. In other words, relatively cheap hardware changes could produce compliance benefits without necessarily changing real-world fuel use very much. One of the more interesting technical details here is cold weather starting. Ethanol behaves differently in the cold, which is why commercial high ethanol blends are usually trimmed back in winter. In the US, E85 can seasonally become E70. Sweden uses E75 in winter. And in Brazil, flex vehicles historically used a small gasoline reservoir to help start the engine below about 15 degrees Celsius, or 59 Fahrenheit. It's one of those classic engineering stories where the public sees a simple label on a pump, but under the surface there's a lot of careful compromise making the experience feel normal. And that did improve. Brazil's 2009 generation flex engines got rid of the auxiliary gasoline tank. Same shared tank concept. Fewer hassles. That's a nice example of engineering solving a practical problem without changing the whole system around it. The last piece that's easy to miss is that flex fuel doesn't necessarily compete with electrification. It can pair with it. Ford tested the idea with Escape Hybrid and plug-in hybrid demonstrations that could use gasoline or E85. Toyota Brazil later developed a commercial hybrid powertrain that could combine electric propulsion with any gasoline-ethanol blend. That combination makes a lot of sense on paper. The electric side cuts fuel use, and the combustion engine can still run on a renewable fuel blend. So instead of treating biofuels and electrification like rival camps, these projects suggest they can stack. Whether that becomes a major path probably still depends on the same old things: fuel supply, price, policy, and whether using the technology is easy enough that normal people will actually bother. That's the flex fuel story in a nutshell. The technology itself is real, mature, and in some places wildly successful, but its impact rises or falls with everything around the car. Pumps, prices, incentives, climate math, cold mornings, all of it counts. And maybe that's the most useful takeaway. The engine can be flexible. The system around it has to be flexible too. This episode was generated by Podkey. Create your own at podkey.fm.